Welcome to the first Passivhaus conference in Brazil. My name is Susanne Theumer from the Passivhaus Institute, and I give a short introduction about the Passivhaus standard. Passivhaus consists of 5 basic principles. The first is continuous thermal insulation. The second are Passivhaus windows. That depends on the climate. That could be triple glazing with insulated frames or double glazing that differs according to the climatic conditions. The third principle is the envelope has to be airtight, so as tight as possible. This is a continuous airtight layer. And a thermal bridge reduced design. So all the weak points in the construction, they need to be addressed. And the thermal bridge effects, so the heat losses in winter have to be reduced or even eliminated. Again, this influence, if a thermal bridge has a huge influence or not so much, depends on the climatic condition where the building is located. And the 5th principle is an adequate ventilation strategy. In colder climates, this is typically a ventilation system with passive heat recovery. So inside the ventilation unit, there are the different air streams, fresh air coming from the outside into the building, and the used air is going out of the building, and the used air, the warm air, is preheating passively the incoming colder air. And this is a very effective method to avoid ventilation heat losses in winter. With these 5 basic principles, we can build passive houses all around the world. We calculate those with the Passivhaus planning package, in short PHPP. This is a design tool. It's based on Excel, and it calculates the energy balance of the building, taking into account all the energy that is used within the building. We can also use it to optimize the buildings, and we use it for different kinds of buildings, so we can calculate not only single-family homes, but also multi-family homes and other building types like offices or even swimming pools. It also works for existing buildings. We calculate the energy balance before, so the existing state, and after the retrofit. We can also look at individual apartments within a big building and use a use a step-by-step retrofit. There we have an additional file that is called the EnerFit retrofit plan. And with this plan, we can plan the individual steps so that they can in the end achieve a very highly efficient building after years and years when the retrofit is finally completed. To help this design and the planning process, we use global criteria. We have Passivhaus criteria, and for existing buildings where Passivhaus standard can often not be reached, we have EnerFit criteria. This is for the retrofit with Passivhaus components. 2 methods are available. We can go component by component. So we have a requirement for the windows which we have to fulfill. As I mentioned earlier, this could be a double glazing or a triple glazing requirement. And for each component, wall, roof, doors, and floor slab, we have to fulfill the values according to our climatic zone. I have highlighted the zones that are relevant for the climatic conditions of Brazil. Or alternatively, that depends a lot on the compactness of the building. If we have a very compact multifamily house, we can also more or less automatically achieve a very low space heating demand. Passivhaus would be a space heating demand below 15 kilowatt hours per year, so not zero, but nearly zero. And for EnerFit, we allow 25 kilowatt hours per square meter and year. So again, this would be a very low space heating demand, and this is the so-called energy demand method. So we don't have to fulfill the strict criteria component by component, but achieve in total a very low space heating demand. The EnerFit seal stands for the quality assurance for refurbishments. And this helps not only the client, but the whole people involved in the construction sector to define or to immediately see the quality of this building. It helps for market transparency and thus is a guidance to reach the not only energy, but also the energetic optimum. Here is an example of a Passivhaus retrofit in Italy, where not only the EnerFit seal, but also the Passivhaus seal was achieved. The space heating demand is below 15 kilowatt hours per square meter and year. In cooling climates, there is also a requirement to achieve a very low cooling demand. The PHPP tells us the limits. For a temperate climate like the one in Porto Alegre in Brazil, the same 5 principles we saw earlier apply. A continuous thermal insulation is the first key. A U value of below 0.3 watt per square meter Kelvin has to be achieved. These values are rough guidance values, and if you enter the individual building into PHPP, you will see the how far away you are from the requirements, or if you have to optimize a bit more. The U value for the installed window needs to be below 1.05 watts per square meter Kelvin. The thermal bridge effects should be avoided, and here a thermal bridge-free design is helpful. There are a lot of realized buildings documented where you can find examples how to do that in practice. We need not only energy efficient windows, but also external shading devices for those windows to avoid excess heat in summer. The airtight envelope, this requirement is true for all over the world, should be very airtight, a value of an so-called N50 value, so at 50 Pascal pressure difference between inside and outside, measured with an airtightness test, should be 0.6 per hour. And finally, the 5th principle is an adequate ventilation. This is achieved with a mechanical ventilation system with heat recovery with an efficiency of at least 75%. If you apply those principles, you can get a certified Passivhaus. Because this building will have a very low space heating demand, lower than 15 kilowatt hours per square meter year, and also a very low cooling demand of below 15 kilowatt hours per square meter and year. Alternatively, you can have a very low heating and cooling load of less than 10 watts per square meter. The airtightness, we saw that before, is also very, very good. And all the electrical appliances and the heating system and the cooling system are also efficient and achieve a total primary energy demand of below 120 kilowatt hours per square meter in year. For summer comfort, the frequency of overheating is below 10%. This can be calculated very reliable with the PHPP tool. The PHPP tool exists since 1998 and is a tool that was used and is constantly optimized since then using field measurements. So we have here the energy demand for heating, and this energy demand, depending on the persons living in the buildings, is if a very energy saving person is living there, is lower, or if we waste a lot of energy, or if we need more heat in winter to keep us warm, then we need more energy than the average. So this curve is very typical. Here on the left-hand side is an existing building stock, and the average of 158 kilowatt hours per square meter in year. This is measured values. And for low energy houses and for passive houses, the curve has the similar shape, but much, much lower, up to 10 times lower. And PHPP calculates without a performance gap. So we don't have a discrepancy between the calculated and the real results. The climatic conditions in Brazil are different, and that has to be taken into account. So PHPP needs the climate data sets for the city where you build, and bases the criteria automatically according to the different situations. As we can see here, for the different cities, they are mostly cooling dominated, and we have not only sensible cooling, which would be the standard case, but also latent cooling. So that means there is sometimes a need for dehumidification. We don't want the hot and humid weather to enter into our building. So we try to keep not only the heat, but also the humidity outside of our buildings. When we look at the 7 climate zones defined for the PHPP, then we see that most of the climates of Brazil are in the very hot or hot climate zone, but also that you see that hatch that we need energy recovery in many parts of Brazil, and that is dehumidification. So as I said, in a humid climate, the humidity needs to stay outside of the building. Here on the left side, we have a typical existing building in such a warm and humid climate. Inside, we have 25 degrees and 65% relative humidity, and we achieve that with standard air conditioning. Outside is it's hot and humid, but we spend a lot of energy. So we pay a lot to achieve this comfort, and it's harmful for our climate. To combat climate change, we have a better solution, and this solution is called Passivhaus. We insulate, as we saw before, continuously from the outside with very thick insulation levels, and we introduce an airtight layer. Concrete, for example, is airtight, or there are special airtightness membranes, or even a 3 millimeter thin plaster is airtight. And then we use, to achieve the same comfortable indoor conditions, a ventilation system with heat recovery, but also with energy recovery. Because if we have a high indoor humidity, we don't feel comfortable. So we need fresh air for ventilation, plus a dehumidification device to take out the unwanted humidity in the building. Guidance values for tropical passive houses here on the left in a compared to a conventional house means we need approximately 100 millimeter of roof insulation, here calculated with a thermal conductivity of 0.04 watts per meter Kelvin. The same for the walls, and 80 millimeters of floor insulation. In red, we see the one example for the air tightness layer, which in the climates where the humidity outside is higher than inside, is located on the outside. This looks different, for example, in a cool temperate European climate where the air tightness is typically the interior plaster. Here, again, interior insulation and an external air tightness layer. So a proper design is important. Before you start on the building site, you have to make a good plan and ideally check it with an independent third party. This could be your Passivhaus certifier. To minimize the electrical loads, you need very, very efficient appliances. So here there is a AAA. That means choose always the best energy rating for the fridge and for the TV that you can get in the market. Also shown here is are the ventilation ducts. All the rooms need to be included in the ventilation concept. We need fresh air in the living rooms and bedrooms, and we take the used air from bathrooms and kitchens. We created a network, first in Germany in 2003 and later in 2010 internationally. My colleague Karl Halbach from IFA will tell you more about it in a moment, where we are connecting Passivhaus professionals. So you can search, and for Brazil, I found 2 contacts, and at the end you see, next to the contacts, you see their qualifications. Because all involved in the construction and planning process must be in the know. We need certified Passivhaus tradespersons on the building sites. We need also designers, certified Passivhaus designers, and we need Passivhaus certifiers for independent quality assurance. So if you look on our website about Passivhaus knowledge in Brazil, you will find already a Passivhaus certifier that speaks Portuguese, is course provider and PHPP reseller, which are the organizers also of this conference, Passivhaus Portugal. And the PHPP is already available not only in English and a lot of other languages, but also in Portuguese. And you find one certified Passivhaus designer in the list. Passivhaus works all around the world, and we had only 3 years ago more than 8,000 certified passive houses. And now this is from June 2021, the latest numbers. So we grow exponentially, and we also have 1 certified passive house in Brazil. The first passive house was built in 1991, but now we have also skyscrapers in certified passive house standard. They are pilot projects. We have already various indoor swimming pools, and also residential units with indoor swimming pools certified, as well as Passivhaus supermarkets. And the first Passivhaus hospital is in construction near Frankfurt, in Frankfurt Höchst. Not only in the European climate, but also in Sri Lanka, there is a retrofit with Passivhaus components. It's a huge Passivhaus factory. And in China, there's a window factory made in Passivhaus standard. And as I mentioned, we are very proud that we also have a first certified Passivhaus in Brazil, which will be featured also in this conference by Luis Becerra. Thank you very much for your attention, and I wish you a great success at this conference and with your Passivhaus projects in Brazil.
Hello everybody, and welcome to my very quick presentation about the International Passivhaus Association, IFA for short, that's what we call it. My name is Karl Halbach, and it's a great honor to present at this momentous first Brazilian Passivhaus conference. As you can see on the first slide here is also already our email where you can reach us, info@passivhausinternational.org, and our website is the same without the info in front. Okay, so let's get right into it. It's a quick presentation. What is the International Passivhaus Association? To have it in a short sentence, it is a global network of Passivhaus stakeholders. So we are trying to include architects, planners, manufacturers, so people from a variety of backgrounds to bring the Passivhaus standard forward globally. That's our goal. As you can see on the left, we have currently about 5,100 members, a little more. We have 22 affiliate organizations all around the world, which are our partners, and we have members in over 50 countries. As an IFA member, you can expect member benefits, but I will talk about those in a little later. To boil it down, to bring it to the essence, our motto is think global, act local, which is a fairly well-known motto, but we're trying to advance and communicate the Passivhaus concept worldwide. In order to do this, we're trying to bring knowledge to the local level that has been gained, and also bring the local findings to the global level. So we have the circle you can see here, and we're trying to connect and strengthen the global Passivhaus community, because this is, for us, the only way to make a change in the fight against climate change when it comes to the building sector and more efficient, energy-efficient buildings. As I was saying, here quickly an overview of our membership benefits. I can't go into everything in full detail, but you can see, as an IFA member, you can get access to Passipedia, which is our knowledge database. I'm going to talk about that too. You can get discounts on Passivhaus services. So for example, if you have to buy PHPP, which is an essential tool for building passive houses, the program, you can expect discounts. You can access our webinars, and you're presented in our online member database. You can also get in touch with many professionals in the IFA forum, where also our senior scientists from the Passivhaus Institute are, and you get a digital subscription to the Passivhaus Plus magazine. Also marketing material, community events, and you get our regular newsletters in which we update everyone what is happening around the world. Speaking of the world, a quick look at our maps. You can see we have two colors here. The dark green are countries where we have an affiliate organization. For example, Portugal Passivhaus, our Portuguese affiliate, and the light green color is countries where we have members. As you can see, we have partners in Chile right now, and also members in Brazil, and we are trying to advance. Of course, right now it's still mostly focused on Central Europe and North America, Australia too, but as I was saying before, we're trying to grow the Passivhaus standard worldwide, and we're definitely trying to reach new areas of the globe. One of our big things we do is we collect and disseminate research and updates. So there's always research being done when it comes to Passivhaus, so we're trying to spread it so that people know. We have literature from us, from the Passivhaus Institute, from our affiliates. We have a page with funding legislation, Passivhaus hotels, and also crosswalk studies where we partner with other green standards to even cover more things to make a greener building environment. We have Passipedia. I already mentioned this. This is a very great resource. So you can access it at passipedia.org. There are many, many articles. If you're not a member, not a problem. You can go there. There are a lot of free articles you can browse through. And if for members, there are also more articles that go a little more in-depth. And you can just find a growing interactive body of Passivhaus knowledge on this website. So please check it out. We also have our IFA blog, where we have a variety of articles. I'm not going to go into all our articles here, but as you can see just from this little overview, we have an article on thermal bridges, which is of course very basic to the Passivhaus principle, eliminating thermal bridges. But we also have interviews with Passivhaus professionals like Miva Mori here or Robert Shield, just to talk about their personal experiences. And we have an article about the Passivhaus standard in a factory in Sri Lanka, which was very cool. So a lot of things to discover there. We have our IFA webinars that I'm doing those with partners from the Institute, the Passivhaus Institute, but also with external partners. These are regular events. You can see the schedule here, but you can also find it on our website. And this is just the second half of 2021. We had 5 webinars in the first half. And the next one, as you can see, if you look here on October 13th, for example, Zeno Bastian, a colleague from the Institute, is talking about preventing energy lock-in step-by-step retrofit to Enerfit. So retrofitting, of course, also a very important topic to make the built environment more energy efficient. These webinars are free for IFA members, but even if you're not a member, they're accessible for a very small fee. The press and media. So we're also, as you can see here, that's just a little examples from our work. We do a lot of infographics. We do videos, brochures, flyers, everything that tries to grow the Passivhaus standard again. So we're trying also, of course, to get people in that may not be familiar with the Passivhaus standard, that really didn't pay attention to it or energy efficiency in general. So by doing these, we're trying to reach a lot of different people to make people more aware of what needs to be done to fight climate change, quite frankly. We have our International Passivhaus Open Days. This is a great event. So we have people from around the world, Passivhaus owners, architects, that open their houses, show their projects, and let people in. Of course, Corona has changed things a bit, so we have switched to an online format, right? This time around in November, as you can see, November 5th to 7th, we will do a hybrid event. So that means we'll have, where it's possible, people can come and visit, and we'll also have the videos. A great thing is on our YouTube channel, you can find old videos. You can go there right now, type in International Passivhaus Association into YouTube, and find all the old videos, look at tours around the world. It's very cool. And last but not least, we're of course also on social media. You can find us here. You can see our different channels. And yeah, we're doing news updates and upcoming events from all over the world, not just from us, but also affiliates, we have a wide range of topics, highlight Passivhaus case studies, and publish our articles and videos, and everything is there. You can also use those to get in contact with us very easily. So that's always a great resource to directly communicate. Okay, that's it. I hope you enjoyed my little presentation on IFA. If you have questions, get in contact with us, of course, and have fun at the first Brazilian Passivhaus conference. Thank you.